right. So again, we are recording so that we can help students who don't make it today. Let's see.
Joe's there.
There we go.
Yeah.
Good morning, Joe. All right. So getting started. I wonder if I can hide myself down here. I think I can. There we go. So reading number 1. Anyone want to read it for us?
Just like the old days.
I'll get started because I know it's hard to keep in line. So Jill invests $400 in a savings bond. The value of the bond, V of X, in hundreds of dollars after X years is illustrated in the table below. So at 0 years, we had 4. At 1 year out, we have 5.4, 2 years out, and so on. The one thing we do notice is that it's increasing. It's going up every time here. So which equation and statement illustrates the approximate value of the bond in hundreds of dollars over time? So there's going to be 2 answers we're going to eliminate, because if we're going to invest money, is the key word at the top of the question, we want the money to grow. So seeing that the money is going up every time, I'll get the hang of this writing thing in a second. We're going to eliminate choices 2 and 4. We don't want it to go down. And could anybody, Ian or Lizzie, maybe tell us 1 or 3? What do you guys think?
3.
Yeah, because the number inside the parentheses needs to be bigger than 1 for our exponential growth. So remember the formula, y equals a, 1 plus the rate to the t power. So that's a formula that we can do without needing the graphing calculator necessarily. So moving on to question number 2.
Can you guys think of anything else that's growing exponentially right now?
Cases of coronavirus, right, Ms. Jopkins?
I swear, what? Coronavirus, yes, it's growing exponentially. That's why we were all home, so it stops growing exponentially.
So looking at number 2, last weekend, Emma sold lemonade at a yard sale. The function P of C equals 0.50C minus 9.96, represented by the profit P of C. So that's talking about the profits. Emma earned selling C cups of lemonade. Sales were strong, so she raised the price for this weekend by 25 cents per cup. Which function represents her profit? So a couple keywords there are going to be raised by 25 cents. So we know that it's going to go up by 25 cents. Which function represents her profit for this weekend? So we have to decide what part of this function is going up. Is it the amount per cup? So 0.50C, remember, is what's multiplied every time times C. And that 996, anybody think they know what that represents in this function?
When you start a business, do you just automatically make profit?
Nope.
No. So what do you have? What would that money be there? Minus 9. What's that, Jeff?
Starting amount.
Yeah.
Well, not the starting amount, like your costs, your starting costs, like the lemons and the sugar and bottled water, whatever you have to be.
Right. So it's this 0.50 that's going to increase by 25 cents per glass. So the best choice, our costs aren't changing, but the amount we're charging per cup is going to go up. So that's the slope essentially in this formula. So the best answer here was choice 4. Looking at number 3, what are the solutions to the equation 3 times x minus 4 all squared equals 27? Now we solved these equations a couple different ways. What I'm going to do is rewrite it. 3 times x minus 4 squared equals 27. Now the deal with this is we could take these parentheses, expand them out, and do a lot of work. But we could also solve by taking square roots. So we're going to solve with a square root here. So what we're going to do is try to isolate this x minus 4 all squared. So here it says 3 times x minus 4 squared equals 27. We're going to undo the multiplication with dividing by 3 on both sides first. So here we have x minus 4 quantity squared equals 9. Again, we could expand out and do a lot of work, or since we can undo a squared by taking square roots, I'm going to square root each side. So the next line down here will read x minus 4. Can you guys still see that? Okay. Equals, and the square root of 9 is really plus or minus 3 because we have two answers. When x has a squared in it as an exponent, we know we're going to have two answers. So this is where we kind of branch out into our two cases. We have x minus 4 equals the positive 3, and x minus 4 equals negative 3. And then we're going to solve each for x. So here we'd add 4 over to get x's positive 7. And x minus 4 equals negative 3. Again, I'm kind of off my screen here. When we add 4 to a negative 3, we get x equals 1. So the best choice is going to be choice 1 there for number 3. Could someone read us number 4?
I got you.
Thank you, Joe.
A relation is graphed on the set of the axis below. Based on this graph, the relation is...
So we have 4 choices. A function for choices 1 or 2, or not a function. Who remembers the function rule when it's graphed? Anybody?
Something with a line. What do you have to do with a line there to see if it's a function?
Yeah.
Do you remember?
I think Lizzie just said it.
Oh, what'd you say, Lizzie? Vertical line.
The vertical line test. So function, so it is a function because it passes that vertical line test. So if I kind of drew a vertical line here and I drag it across the screen, let's see, it won't let me grab it, will it? Nah, I tried. I'm used to our whiteboards in class. It's only going to touch the graph at one place. So every time I draw a vertical line through my graph, it only touches in one place. Okay. Moving to the next side. Couldn't preview file. Interesting. I'm just going to click into it again and try one more time. Miss Lack has a couple options here. I think I do at least. Sorry.
Did we put a video up for this one yet?
That's...
For 3, yeah.
No.
No. Hey, Joe, did you see my message about the back pages?
Yeah, I sent them all in.
Okay. I don't know why your stuff wasn't showing up.
It's locked in.
Yeah, I'll check mine later too.
So let me go into our assignment instead. I can find it here. Sorry, guys. Technical difficulties. You know how this works. Joe, do you prefer being in class or what, kiddo? Do you prefer class or doing this?
It don't matter to me.
No. Coronavirus is never going to come here. I think I remember hearing that coming from your... Here we go. Last choice. There it is. All right. Sorry, guys. Took me a second to find it. Number 5. If the original function f of x equals 2 times x squared minus 1 is shifted to the left 3 units. Okay. And even remember what kind of function this is? We have linear functions, constant, quadratic, absolute value.
Quadratic.
It's quadratic. So the shape of that function will be some kind of U shape if we were in the coordinate plane. So if we want to move that U over to the left 3 units, so if we want to kind of take the vertex and move it to the left 3 units, typically we could try to type into the calculator here for something like this. But does anybody remember the shift rules to move to the left 3 units?
Oh, to the right.
You have the right idea. It's opposite.
Yeah.
So if you want to move to the left, and what are you doing with the number? Where are you putting it?
We're gonna add 3 somewhere. So the adding 3 is gonna go into a set of parentheses. So we're not looking at choices 3 and 4. It looks like they added 3 to a -1 to get this 2. That is the shift that goes up and down. So if we had taken 2x squared minus 1 and added 3 to the end, that would shift you up 3. But since we want to go to the left 3, we're going to take x plus 3 in the parentheses squared minus 1. So the best answer here is going to be choice 2. I noticed in my packet that number 6 kind of copied a little funny. So if you guys can't see all the lines on your graph, just bear with me and watch on your screen here. But looking at where these 10s are, it's going to make a difference on the scale. So if I only have 1, 2, 3, 4, I'm trying to tap the screen. I don't know if you see it. 5 boxes going up, that means each box is going up by 2s. Okay, so that's one thing I want to note first before we read the question. So with number 6, it says determine if the point 0,4 is a solution to the system of inequalities graphed. So the point 0,4 has an x coordinate of 0, y of 4 would be up to 4. It's where those 2 lines are meeting. So we have to decide, is that a solution to this graphed system of equalities? Yes or no? No. Was that Lizzie? I think I heard. Yeah. Okay. So the answer is going to be no, but we need to explain. So justify your answer. Anyone have an explanation for us?
No.
No. The solution can't be on a dotted line. Okay. So the solution point cannot be on a dashed line. Did we wake you up, Joe?
Yeah.
Well, thank you to Lizzie for that.
I just know.
Oh, okay. It works. So moving up to number 7. Am I going too fast for anybody? Are we okay?
Good. You're good.
All right. Thanks, Ian, for checking in. I thought we lost you because I can't see everybody with the screen I'm on right now. So looking at number 7, the drama club is running a lemonade stand to raise money for its new production. A local grocery store donated cans of lemonade and bottles of water. Cans of lemonade sell for $2 each bottle, and water sells for $1.50 each. The club needs to raise at least $500 to cover the cost of renting costumes. The students can accept a maximum of 360 cans and bottles. So here we had a lot of information kind of given. We have cans of lemonade that cost $2 and bottles of water that sell for $1.50 each. So let's kind of give ourselves 2 let statements. So we have lemonade is $2 per one, and we have water that is $1.50 for each. Okay. And the amount of money total that we want to raise is at minimum $500. So I'm going to kind of box in the words at least 500. And also the students can accept a maximum of 360 cans and bottles. So write a system of inequalities to represent each used to represent the situation. So remember, inequalities are greater than, less than, greater than or equal to, less than or equal to equations. So if we start with the first equation, we have two variables. We're going to have lemonade and water. So lemonade, I'm going to have be the letter X, and water be a variable Y. So our first equation, we take X and Y, and they're going to be compared to how many total cans and bottles can we get to. So the number of cans and the number of bottles of water, X plus Y has to be a maximum of 360. So what is maximum going to be? A less than or equal to, greater than or equal to? Okay. A maximum means we can't go over it. So it's going to be less than or equal to 360. And then the next equation, we need to talk about the costs. So we have $2 per X water. So we can write 2X plus $1.50Y is something compared to the $500. So at least, remember, least is usually lower, but we kind of flip-flop it here. Kind of like less than is subtraction. It's a turnaround word. So here, at least is going to be greater than or equal to $500. So that gains you those two equations, that system of equations is what the first part of the question was asking for. So if this was a 4-point question, that alone would get you 2 of your 4 points. From here, I'm going to kind of shift up my page a little. Now that I have those equations, I'm going to answer the second half of this question, which refers to the club sells 144 cans of lemonade. What is the least number of bottles of water that must be sold in order to cover the cost of renting the costumes? Justify your answer. So when they have you justify your answer, that's just solving the equation is enough work to kind of get you credit here. So 144 cans of lemonade, X was my lemonade. I'm going to put 144 into the X here, and we can solve for the Y. So we're going to use the first equation. If we sold 140,
we're talking about money. I used the first equation when I did it, but I'm wondering. I mean, it's not going to.
It doesn't matter which equation, right? Because
more than
I use this. I used the second equation, Ms. Hopkins, and I got 141.33, and then that has to be interpreted.
Yeah, that's what I did.
Right? But let's use the first equation. So 144 cans of lemonade has to be less than or plus Y is less than or equal to 360. And we subtract 144. 360 minus our 144 leaves us with 216. So we have to sell less than 216, but we also have to sell more than, because if we sold 2 bottles, that wouldn't be enough. We wouldn't hit the cost of $500. So we do have to use the second equation here as well. So if you have that written down, great. I'm going to run out of space on my screen here because my laptop's kind of small.
You can erase it.
Yeah, I'll erase what's over here. There it goes. So now using the second equation. So I'm going to put the 144 in for X in our second equation instead. So if we take 2 times 144 plus 1.5y is greater than or equal to 500, the money is really the case that we need to be a little bit more diligent about finding. So here, 2 times 144 is 288, and we can subtract that from 500. We left with 1.5y is greater than or equal to 212. And then the calculator, if you divide over by 1.5. X is greater than or equal to 141.33. Now, we can't leave a decimal there because it asks for how many bottles of water. Now, we can't buy a third of a bottle of water. So here, if we have 141, we can test it back into the equation, which is where I'd love to bring up a calculator. But if, in this case, we're going to round down. We're going to keep it to 141. Nope, I'm sorry. We're going to round up because we want to earn at least more than the 500. So the best answer here is going to be 142 bottles. Sorry, I'm kind of all over my screen, guys. But I think we get the case. Because yx, my variable is backwards. Y should be greater than or equal to 141. So we're going to bump up to 142 bottles of water. So that was our whole mixed review number 3. Ms. Hopkins, did we want to talk about the most missed questions on the other 2 assignments, or just kind of ask them to watch the other videos that we've made?
Say that again, sorry.
It's okay. Do we want to roll back to midterm mixed review 1 or 2, or just kind of leave it at mixed review 3 today?
I think leave it at that, unless there's a question that you guys had, because I think we have videos up for 1 and 2, don't we?
Yes.
So why don't we leave it at that? Do you guys have any questions?
It's not about that. Do you think we're gonna go back?
If we had that answer,
Like,
we would be
it could a while
millionaires.
longer.
I'm
I
with
think-
Jill on that one.
I suspect we will be back, but I